This is video 5 for College Algebra, and today we're going to be going over complex numbers. So first of all, the imaginary unit I, okay, and you might have seen that before, heard about it, but we're actually going to be utilizing it. And so what I is the square root of -1, okay, and because that is not possible, we come up with this imaginary unit, okay. And something else just that we need to know is I squared equals -1. Remember, when we multiply two square roots, it's just whatever is underneath that square root. All right, and standard form of a complex number, complex meaning it has imaginary and regular numbers, would be a plus bi, okay? And the a is your real number. The b part is your imaginary part. All right, so for example, the square root of -4 would be 2i. Square root of -81, 9i. Okay, this would be 2i square root of 5. Okay, the I goes in the front of a radical sign. Okay, a square root of -50 would be 5i square root of 2. Okay, and then I want to show you with your calculators, with your graphing calculators, if you go into your mode and you turn on, make sure that this a plus bi is highlighted, okay? Then that means your calculator will have the imaginary unit. So if I took the square root of -81, it would tell me that it's 9i, okay? And so this is good to check your answers. Today in these notes, though, for the most part, we're going to be using, we're going to be working out these problems by hand. All right, so for adding and subtracting, we're just going to find the combine like terms, okay? So we add not real parts, so 4 plus 1 would be 5, and we add our imaginary parts. So we've got 5 plus 13i. And whenever you're writing a complex number, make sure your real part of your number goes first and then your imaginary part. All right, with this next one, we've got these negatives, so we're going to have to distribute those negatives. So I've got 3i, this turns to plus 2, minus 3i, minus 2, and minus 5i. Okay, if we're looking at our real parts, those are going to cancel out. We've got a 3i, negative 3i, those cancel out. So we're just left with -5i. All right, when we multiply, it's just like normal. We are doing our distribution. 4 times -2 would be -8. 4 times 3i is 12i. Okay, it gets a little more hairy whenever we're double distributing. So we've got 8. And then we've got plus 6i, minus 4i. And then when I multiply my -i times my 3i, I would write that as -3i squared. And then off to the side, we can say, well, I squared is -1. This is just simply -3 times -1. So this would actually be plus 3. All right, so I've got 8 plus 3 would be 11, and adding my imaginary parts, I get plus 2i. All right, when we square a number, remember, we have to write this out twice. You can't simply square each number. You've got to write it out twice and then do your double distribution. Okay, So after we do our double distribution, we would get 3 times 3, which is 9, plus 6i, okay, plus another 6i, plus 4i squared. Okay, this 4i squared simplifies to -4. So we'd have 5 plus 12i. Now when we've got a difference of squares, okay, or if not a difference of squares, but if we have two two complex numbers that are conjugates of each other, aka one has a positive, one has a negative, and they're the same numbers, you will get a just real number as your answer because our imaginary parts will cancel out. 3 times 3 again is 9. We've got plus 6i, a minus a 6i, and minus 4i squared. That's going to change to positive 4. Okay, our 6 i's, those two cancel out, and we're just left with 13. Okay, for our last two examples, we're multiplying by the complex conjugate, which, remember, our complex conjugate, we've got a plus bi, a minus bi, okay, and that's kind of what we happened on number 6. All right, so for this one, we're going to multiply by the complex conjugate, which would be 3 minus 6i. All right, so when we multiply, we've got 9, we've got minus 18i plus 18i, and minus 36i squared. Okay, so this would simplify to 9 plus 36, which is 45. Okay, and you can always check your answers on your calculator. All right, this next one we're going to multiply by the complex conjugate, which is 3 minus 2i. If you multiply on the denominator, you've got to multiply on the numerator. Okay, in our denominator, we already know that it's 13. We just did that problem for number 6. On our top, okay, we get 22 plus 7i. All right, we've got a couple other things. We're finding roots with the quadratic formula, and we're going to have some complex answers here. So with our quadratic formula, x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay, once we figure out what's underneath our square root, this simplifies to 2 plus or minus the square root of negative 56 over 6. All right, we can reduce that radical, and we've got 2 plus or minus this 2i square root of 14 over 6. We can reduce that with using a factor tree. Okay, and notice how we put the I on the outside of the radical, not behind the radical. And because we have these three numbers that can reduce, we can simplify our answer even more to just be 1 plus or minus I square root of 14 over 3. Okay, and remember, anything under that radical is locked in, so you cannot reduce that at all. All right, and here's just, again, those notes on how to put your graphing calculator into complex number mode. All right, this has been complex numbers for college algebra.